Automated testing is considered an essential part of any serious software development effort. Automation makes it easier to repeat individual tests or test suites quickly during development. With Nest.js, we can use any testing framework we prefer. However, it can be quite tedious to set everything up. Luckily for us, Nest provides a built-in integration with the Jest testing framework out of the box, so we don't have to do anything to get started. Jest is a delightful JavaScript testing framework with a focus on simplicity. It allows you to write tests with an approachable, familiar, and feature-rich API that gives you results quickly. Jest provides great error messages and built-in mocking utilities to make testing your applications much simpler. Also, it reliably runs tests in parallel. To make tests run even faster, Jest runs previously failed tests first and then reorganizes test runs based on how long test files take. In Nest.js applications, we use Jest to run unit tests and end-to-end tests. There are several commands you can use to run specific tests. npm run test for unit tests, npm run test cov for unit tests and collecting testing coverage, and lastly, npm run test end-to-end for end-to-end tests. With Nest, we automatically have all of this power with no additional setup needed. So far in this course, we haven't paid too much attention to testing. Thus, some of the existing or automatically generated tests may fail. In the next few lessons, we'll introduce you to the Jest framework, show you how to use Nest.js testing utilities, and fix some of the existing test files, all step by step. Testing by itself is quite the endless topic that could be fragmented into many separate videos. Since we can't really cover every aspect of testing itself, we'll be focusing primarily on how testing works within Nest.js. We'll be focusing mainly on tips and tricks, showcasing some best practices, and go over how you can add and manage tests in your Nest applications. For unit tests in Nest.js, it's a common practice to keep the spec files in the same folder as the application source code files that they test. Each controller, provider, service, etc. should have its own dedicated test file. The test file extension must be .spec.ts. This is so that integrated test tooling can identify it as a test file with test suites. For end-to-end tests, these files are typically located in a dedicated test directory by default. End-to-end tests are typically grouped into separate files by the feature or functionality that they test. For end-to-end tests, the file extension must be .e2e-spec.ts. While unit tests focus on individual classes and functions, end-to-end tests are great for high-level validation of the entire system. End-to-end testing covers the interaction of classes and modules at a more aggregate level, closer to the kind of interaction that end users will have with the production system. As an application grows, it becomes hard to manually test the end-to-end behavior of each API endpoint. Automated end-to-end tests help us ensure that the overall behavior of the system is correct and meets project requirements. To better understand how tests look and how they work, let's open up the Coffee Service spec file we haven't looked at yet and walk through everything step by step. First, we can see that the describe function that defines a block which groups together several related tests. In this case, the describe block is grouping all of the unit tests that concern Coffee Service class. Inside this block, we could see the before each function. This function passed into the before each hook will be executed before every test. This is typically referred to as the setup phase. Often while writing tests, we have some setup work that needs to happen before each test runs. And sometimes you need to do something after each test runs. Just provide several other helper functions to handle situations like this. We know before each now, but the other available options are before all, after each, and after all. So looking at this test file, let's dive into the before each function call here to see what it's doing. At a very high level, we can see that we're instantiating some type of module by compiling a test module and then utilizing this module to get a hold of the coffees service. Then it looks like we're storing it in this service variable to be used within our individual tests inside of this describe block. Let's start by analyzing everything that's happening here. The test class is useful for providing an application execution context that essentially mocks the full Nest runtime, but gives you hooks that make it easy to manage class instances and do things like mocking and overriding aspects of your application. The test class has a create testing module method that takes a module metadata object as its argument, the same object we pass into our module decorators. One important thing to note here is the compile method. This method bootstraps the module with its dependencies, similar to the way we bootstrap our application in our main.ts file with nestfactory.create. The compile method returns a testing module instance, which in turn gives us access to a few helpful methods. Once our testing module is compiled, we can retrieve any static instance declared within the module by using the get method we see being used here. As we can see, we're calling the get method here to retrieve our coffee service from within our compiled testing module, and then storing it in the service variable defined within our describe block. This is a standard practice for testing that allows us to store and use this service within all of our tests that are a part of this describe block. Just as a side note for future reference, if you need to retrieve request scope or transient scoped providers, use the resolve method here instead of get. The next big area in our test file is the IT function call. An IT function represents an individual test. In this automatically generated test, there isn't much going on. The test is currently just checking whether the service variable is defined or not. If the service isn't defined, the test fails. Alright, so let's run this particular test file and see if our one test passes or fails. Let's open up the terminal and run the following command. npm run test watch -- space and then coffees.service. The test watch script will run our unit tests in watch mode, automatically rerunning tests on any file change. We're passing in coffees service here for example's sake, just to indicate that we want to only run the test for this specific file. Typically, we won't need to do this. After running the script in our terminal, it looks like the testing module couldn't bootstrap properly and it's throwing some errors. But what happened? Since the coffees service class depends on many other database-related providers like connection or entity repositories that are not registered in the testing module, Nest throws the Nest can't resolve dependencies error. So how can we fix this? Let's head back to our testing file and look at the module's metadata again. Our testing module consists of only one provider, which is coffees service. In theory, to fix the error, we could just add the required providers here into the providers array. However, this would be against best practices and the general philosophy behind unit tests. Unit tests should be performed in isolation, but that doesn't necessarily mean complete isolation. By isolation, we mean that a test shouldn't rely on external dependencies. One philosophy for unit testing is to mock everything in situations like this, but that often leads to fragile tests that are hard to maintain and don't bring any significant value. Our coffee service depends on database-related providers, but the last thing we want to do is to instantiate a connection to a real database just to perform unit tests. So what other options do we have? Without needing to create complicated mocks or connecting to a real database, all we really need to do is make sure that all the requested providers are available to the testing module. As a temporary solution, let's provide all the classes our coffee service depends on using the custom provider syntax. We need to provide connection and our two entities using the getRepositoryToken function, making sure to import it from Nest.js type-orm package. GetRepositoryToken accepts an entity, in our case, flavor and coffee, as an argument and returns an injection token. For now, let's just give all of these providers an empty object for a value. Once we start testing specific methods, we'll replace these empty objects with mocks. Let's save everything and open up the terminal again to see if these changes worked. As we can see, the testing module was properly bootstrapped now, and our basic generated test doesn't fail anymore. Great. But we still have plenty of work to do in the following lessons. There are many different strategies on how we can structure our test suites. When testing services or similar classes that contain business logic, we prefer grouping the related tests by methods, using method names as our describe blocks. In this video, let's figure out how we can test the find_one method. One problem we'll notice is that the find_one method uses coffee_repository.find_one inside of it. We'll have to make sure to mock this repository method for our test to run properly. Looking at the code here, it seems that depending on whether a coffee exists, there are two different scenarios we must cover with a unit test. Let's head back to the spec file and start by defining a new describe block. Inside this block, let's first define the success path. This part is pretty self-explanatory, but we want to name our describe and it functions with actions. As you can see, we have describe when coffee with ID exists, and it should return the coffee object. These are very descriptive, easy to read, and it gets right to the point of what exactly this test is covering. All of these names get output into the terminal when our tests run, so it's always helpful to make these names and descriptions very specific. So back to our test at hand. In our find_one method, when a coffee with a specific ID exists, we want to test if the method returns the coffee object, or in our case, the coffee entity. Let's leave the implementation blank for now. Next, let's define a test for the failure path. Here, we're describing a test for when a coffee doesn't exist, explaining in the it function that we expect the find_one method to throw an exception. Alright, with this in place, we can now start writing the test logic itself. Inside our success path test, let's add the following code. In this test, we're hard-coding a random ID and calling the find_one method of our coffee service with this ID passed in as an argument. The important part here is the actual test itself, which is that we expect coffee to equal expected coffee. There are many different ways to assert these tests. After you declare your expect, push dot, and check your IntelliSense to see all of the other great options for test assertions. Alright, so let's save our changes so far, open up the terminal, and see what Jest shows us now. It looks like we're getting the type error, this.coffeerepository.find_one is not a function error. In the previous lesson, we used empty JavaScript objects as our entity repositories. Obviously, these JavaScript objects don't have any methods defined, so it makes sense we're seeing this error. So, how can we fix it? There are many different ways of how we can mock repositories or any other classes we need to mock. For example, we could use the object.create function and pass in the repository class prototype to initialize the repository object without any dependencies. But in the long run, this isn't the best idea. In this case, TypeORM plans to remove the repository class entirely at some point in the future. They might use literal objects instead one day. Although that is specific to this situation, it shows that we need to be careful with third-party libraries and potential changes they make, and how those changes can even impact our tests. Another way would be to create a generic function that simply returns a mocked object with all the same methods that repository class provides, and then stub on these methods to manipulate their behavior based on certain conditions. It could potentially look something like this. Note that this is just for illustration purposes. There are many other methods that we didn't cover here in this mock. So let's analyze this code real quick. First, we have a new mock repository type, which represents an object that consists of some of the properties that the repository type contains as well. However, all of these values are of type jest.mock, which is a mock function provided by Jest. Then we have a createMockRepository generic function that returns this newly defined mock repository class. When the type argument is not provided, it falls back to any. Just keep in mind that we're not implementing every method for repository. We could obviously add more here if we needed them for our tests. Alright, with our mock function created, let's replace those previously used empty objects with this createMockRepository function call. Great. Now for the second step. We need to make the coffee repository variable available in our test functions. To do this, let's define a new variable under where we have service coffee service and name it coffee repository of type mock repository. Now in our before each hook, let's retrieve the value and set it to this variable. Now we can move on to our test again and mock the find_one method. If you type coffee repository.find_one and type dot after, you'll see various methods available to us now thanks to Jest. Since we simply want to mock that this find_one method returns back our expected value variable, let's just use mock return value method and return expected coffee. Let's save our changes and open up the terminal again. As we can see, our test succeeds now. Great. Lastly, we need to finish the test logic for the failure path. Let's head over to VS Code again and add the logic in the other IT block. In this code, we can see that we're also using mock return value, but passing in undefined this time. This mimics a response that our entity does not exist in the database. If everything works as it should here, the service should throw a not found exception with the expected error message, which is coffee #ID not found. We're wrapping all the code here in a try catch just to make sure we capture any exceptions that will obviously occur here, since we mocked the find_one return value to be undefined. Let's once again save our changes, open up the terminal again, and see if everything works properly. Perfect! As we can see, all of our tests passed. We can see how nicely structured Jest outputs everything as well. All of our describe blocks, nested describe blocks, and it functions are all nicely indented here with their descriptions all output for us and extremely easy to read. Although we just scratched the surface of unit testing in general, the principles and concepts we learned here can be applied to almost any situation you may run into while applying unit tests to your Nest.js applications. End-to-end testing covers the interaction of classes and modules at a more aggregate level, closer to the kind of interaction that our end users will have with the production system. In previous lessons, we learned how to manage unit tests in our application. Now let's shift our focus to how we can create and structure end-to-end tests for our system. Let's start by opening up the existing app end-to-end spec file located in the test directory to better understand how we can create our own end-to-end tests in the future. As we can see, end-to-end configuration here looks very similar to what we saw in our unit test suites. However, there are a few key differences that we should pay attention to here. We're using the compile method again we used in our unit tests, but for end-to-end tests, we need to use the createNestApplication method to instantiate an actual Nest runtime environment. Instead of saving a reference to a service like we did in our unit tests, here in end-to-end tests, we're saving a reference to the running application in the app variable so we can use it to simulate HTTP requests. Lastly, we need to manually call the init method to initialize our application, which will mount all of our routes, trigger lifecycle hooks, etc. So that's it for the initial setup. Let's look at how an end-to-end test is actually structured. If we look at the it block here, we can see that we're simulating an HTTP request with help from the library supertest and calling the request function provided by it. Supertest is an NPM package that provides a high-level abstraction for testing HTTP applications. We need these HTTP requests to route to our running Nest application. This is why the request method needs to be passed a reference to the HTTP listener our Nest app is running on, which may be Express or Fastify depending on how we set up our app. This is what app.getHTTPServer is trying to do. The call to request now hands us a wrapped HTTP server connected to our Nest application. We now have the ability to chain methods here to simulate an actual HTTP request. In the example shown here, we're using request.get with the string / inside of it. This will initiate a request to our Nest app that is identical to an actual HTTP request coming in over the network. Since we still have that demo app controller on the root level of our application, which in turn replies with the hello world message, this test should succeed. To test it real quick, let's open up the terminal and enter in npm run test:/e2e. As we can see, the test is actually failing, and the error message is expected 200 OK, got 403 forbidden. This is caused by our API key guard mounted globally that we created in a previous lesson on other building blocks by example. Just to remind ourselves, the API key guard requires us to pass a hard-coded API key within a header. Since the root route we're trying to hit here isn't decorated with the public decorator we previously set up, we need to pass this header in the request for the test to pass. We can fix this real quick by opening up VS Code again and chaining a set method to our HTTP request. This method lets us set any headers we might need. So here, we're just going to pass in that authorization and the key we previously set in our env file. Let's save our changes, open up the terminal, and see what Jest gives us now. Perfect. It seems that our end-to-end test succeeded now. However, we can also see that we got a warning. Jest did not exit 1 second after the test run has completed. This warning means that there are some asynchronous operations that weren't terminated in our tests. In this particular case, it's an opened database connection. Back to VS Code again. Let's add the after all hook below all of our tests. This after all hook will be called by the Jest framework after all tests are completed. Here we called app.close, which lets Nest know that it should trigger the onModule destroy and onApplication shutdown lifecycle hooks, which will terminate all connections in our application. For the sake of consistency, let's also change our before each here to before all, since typically we don't want to recreate the application for each end-to-end test. Just to make sure that everything's working as expected, let's open up the terminal again and run npm run test:/e2e for the last time. Great, as we can see, everything's passed and we have no more errors or warnings. Although we fixed this end-to-end test and it's working properly now, it's still far from perfect. We're importing the app module here, which means that in fact we're instantiating the entire application, including all controllers, providers, enhancers, configurations, establishing database connections, and so on and so forth. Nest modules typically represent features, so ideally, we should be able to test these features in isolation independently. In the next lesson, we'll look at how we can test modules in isolation without worrying about other modules that might have been imported into the application. Grouping our application's functionality into modules is strongly recommended as an effective way to organize our components. For most applications, the resulting architecture will employ multiple modules, each encapsulating a closely related set of capabilities. Because of this encapsulated organization, this allows us to test each feature independently by importing a specific module that we want to test into our testing module. In this lesson, we'll be testing the coffees feature we worked on throughout this course and test some of the CRUD endpoints we provided in it so far. To get started, let's create a new folder within our test directory named Coffee. Within this folder, let's create a single end-to-end test file named coffees.e2e-spec.ts. Inside this file, let's start by creating the basic structure for our test. As we can see, we have a top-level describe block again, which represents our test suite. Within this block, we have the before all and after all hooks again, representing the setup and teardown phases of our tests. And lastly, within our testing modules imports array, we're passing in Coffees module this time. We haven't implemented any tests yet, so let's add a few placeholders and we'll work our way through these in a few moments. With these it.todo reminders in place, we won't forget to cover all the important scenarios later. To-do, provided by Jest, is a great way to track tests that need to be completed in the future, as they even show up in the Jest report to help remind you. Alright, so let's run this particular test and see if any errors pop up. Open up the terminal and let's enter in the npm run test e2e command again, but passing in the -- flag with coffees after it. It looks like we're getting an error, but we've seen this one a few times now. It's the Nest cannot resolve dependencies error. If we look at the error description, we can see that the connection provider is missing. Since our application uses a database as a data source, and we leverage repository classes heavily within the Coffees module scope, the testing module cannot properly bootstrap. But how can we fix this? Well, there are many different approaches to tackle this issue. The first option we have is to mock interactions with the database. We could override all the providers and replace them with mocked objects, stubbing methods, and manipulating the returned values. This does give us full flexibility and isolation, but as for a con to this approach, it's time-consuming, very error-prone, and hard to maintain, plus we can't test any interaction with a real database or test any plain SQL queries. Another option is to use disk-based databases, for example, SQLite. With this approach, we don't have to mock anything or stub on any methods. It's easier to maintain and doesn't add any complexity or overhead. It's fast and easy to set up. However, it works for simple scenarios when we don't use any database management system-specific features, such as Postgres-related features in this case. Some queries might fail for Postgres, but not for SQLite. We don't really test the entire flow. And one other option we have is to add an additional testing database. This way we don't have to mock anything or stub on any methods. It's easier to maintain and we use the same database, for example Postgres in our case, so our end-to-end test will have the same flow as our real application does. Some cons to this approach: it does add more complexity and overhead since we need to start and close the database for end-to-end tests, both locally and in the CI/CD pipeline if we have one. Note that deciding which approach to use heavily depends on your application's requirements. In this lesson, we'll be going with the third approach as it's the most reliable way to do a real-world test of our features using the same type of database. The additional complexity and overhead is not a big issue since we're already using Docker in our application. Alright, so let's get this set up by opening up our Docker Compose file and add another database in there. We're going to use the same configuration options as for the original database, with one minor difference. We need to make sure that our ports aren't in conflict. So we're mapping port 5432 to the port of 5433 here instead. With this in place, let's open up our package.json file and define pre and post hooks for our test end-to-end script to make our lives easier and somewhat automate this process. If you're not familiar with these hooks, NPM scripts allow us to add lifecycle hooks to our scripts simply by prepending pre or post to a similarly named script. With these NPM lifecycle hooks set up, our database will be automatically started before running end-to-end tests and closed right afterwards. Lastly, let's head back to our coffees end-to-end spec file and import the typeorm module.forRoot to initialize a connection to this new testing database we just created. Note the different port of 5433 being used here. Now, if we open up the terminal and run npm run test :e2e -- coffees command again, as we can see, this time there are no errors. We can also see that the database container was created before running the tests and was closed immediately after they completed. Great! With this setup, we're ready to start implementing our actual test logic, which we'll do in the next lesson. We did a lot in this video. To summarize, we created a new test for just our coffees module, created a new test database in our Docker Compose file, and even added some cool NPM hooks to help start and close our database whenever our tests run. With a lot of this in place, we're fully ready to handle end-to-end tests for our application as it continues to grow in the future. In the previous lesson, we created a boilerplate for our test and even set up a test database for all our future end-to-end tests. In this lesson, let's focus on adding real logic to all of our to-do end-to-end tests and ensure that our CRUD coffees routes work as intended. But before we get started, let's focus on the before all hook here. As we know already, the create nest application method is used to instantiate a full nest runtime environment. You could think of it as an instance of the application that we have in our main TS file. This means that any configuration that was added outside of modules themselves, so basically anything that was done in our main TS file, must be added and applied here as well, unless it's not needed for this particular end-to-end test. For this reason, we need to make sure we bind the validation pipe we have set up here. So let's copy this and paste it over in our end-to-end spec file. Perfect. With that in place, we should be ready to get started testing our endpoints. Let's start off with the create post endpoint. First, let's remove the .todo suffix and add a missing callback function instead. Now, we can use the supertest library, which we've used already to perform an HTTP request to our application. Before we proceed though, let's first define a sample coffee that we can use for all of our other endpoint tests as well. Let's scroll to the beginning of the describe block and add a coffee variable with some key values that belong to our entity, like name, brand, and flavors. With this in place, let's head back to the create endpoint test and add the following logic. In the body of the request, we must send an object that fulfills the createCoffeeDTO class. Note we've added as createCoffeeDTO for better type safety here as well. The test here is currently simple and only expects an HTTP status of created from the API call. But if we needed to test the return value more specifically, we could test it by looking at the value returned back from the promise, like so. If you're not familiar with Jasmine, it's another testing framework that Jest is actually based on. We can't dive deep into Jasmine here, but just know that there are a lot of other great helper and utility methods available to you from Jasmine when creating your tests. In the code shown here, we're using Jasmine helpers for partial matching. This is useful when an expectation only cares about certain key value pairs when performing the actual test. In addition, we needed to transform flavors, which are an array of strings, to objects since each flavor is an entity in our application. Alternatively, we could just create a separate file with expected static responses and DTOs to avoid putting too much repetitive logic like this in our end-to-end tests. But with all this in place, let's fire up our terminal and run our end-to-end tests now. As we can see, the test was successful. As an exercise, try to implement all of the other to-do tests in this file to get a better feel for end-to-end testing yourself. If you're stuck at any point and unsure of how to continue, just scroll down and view all of the completed test code below. So as we've seen in this testing chapter, Nest.js module system allows us to test each feature independently. Isolating specific features makes it easier to develop and maintain tests simply, effectively, and quickly. With the testing fundamentals we went through here, you're now ready to tackle any testing scenario you might run into in your future Nest applications.